after watching this lecture, your concept about this thing derivative will be fully cleared. You will know the geometrical meaning as well as the practical meaning. Geometrical meaning means slope. Then slope of what? Students, how much is this? Plus 2, forward direction, plus 2. Plus means forward, 2 means 2 units. And plus means upward in y direction, and 1 means units. So the slope of this straight line is 1 upon 2. 1 upon 2. So the equation for the distance obtained will be, distance is equal to VIT plus half GT square. You released it from rest. Initial velocity is 0. I want to find the velocity when the body goes from this point to this point. You induced EMF. We are rotating it with constant angular velocity. Velocity is constant, but at each different position, different EMF will be induced. Practical meaning of derivative, it all depends on what do these variables x and y, input and output, what do they represent. With the name of Allah Almighty, dear students and all the viewers, hopefully you all will be fine. I, Dr. Engineer Majid Amin from Peshawar, Pakistan, welcome you to my YouTube channel. I've been teaching mathematics for the last 17 years. My dear students, in this lecture, we will answer this question. What is derivative? FAQ, the frequently asked question. In fact, most frequently asked question of students of intermediate and university level. Sir, what is derivative? We know that if suppose we are given a function y is equal to x square, we have no confusion whatsoever that derivative of this function is this thing and derivative of 4x plus 1 is 4. But sir, we don't have the intuition behind this. We don't have the physical, we don't understand the physical meaning. At the most, if some students have the intuition, at the most they have this geometrical meaning. They don't understand the practical meaning of derivative. So after watching this lecture, your concept about this thing derivative will be fully cleared. You will know the geometrical meaning as well as the practical meaning. Let's get started. My sweet students, you know that what is slope of a line. For example, you are given a straight line. You select any 2 points. Any 2 points, doesn't matter. Students, and then you complete your right angle triangle. This thing called base or run in FEC. This thing called perpendicular or rise. The ratio of rise to run. The ratio of rise to run is called slope represented by M. Hopefully it is clear to you. For example, this is 3 units, this is 2 units. Its slope will be 3 by 2. And if you say that this angle is theta, so tangent theta is also equal to perpendicular upon base rise by run. So this is equal to tangent theta as well. Hence tangent theta and slope is the same thing. So you have 2 possibilities. Either you will be given the angle of a line. For example, I am given this is a line and its angle is 60-degree angle made with positive x-axis. Alright students, so the slope of the line will be tangent 60. Slope is a separate topic to be discussed in another video. But I hope when a student wants to understand the physical meaning, he at least knows what is slope. Students, M is equal to slope. Slope is represented by M. Tangent 60, 1.73 is its slope. Or sometimes you will be given the rise and run. Let's say I am given that this is 3, this is 2. Its slope will be rise divided by run is equal to 1.5. Very much clear. So what do I write? I write that slope. What is the geometrical meaning of derivative? Geometrical meaning means slope. Then slope of what? There are 2 possibilities. Either the given function is linear function. Either the given function is linear function. So you know when the given function is linear function, the graph will be straight line. So derivative of the linear function will show slope of that straight line. What did I say? If the given function is a linear function, its graph will be a straight line, and derivative will show the slope. Derivative is also called gradient. are instantaneous rate of change. Derivative, slope, gradient, instantaneous rate of change, differential coefficients, all of these, they mean the same thing. So if the given function is linear function, the graph will be straight line and derivative will be slope of that straight line. Let's have a look at the graph. I want to make it quickly so that your time is not wasted. Let's have a look at that. All right, student, this is the given function. Of course, it is a linear function. These are some of the points. If you put 0, x is equal to 0, y will be 1. 2 times 0 is 0, 0 plus 1 is 1. Likewise, if you put x is equal to 1, y will be 3, and so on. 0, comma 1 point. This point is 0, comma 1. Next point is 1, comma 3. Hopefully you understand 1, comma 3 point. And students, minus 1, minus 1. If you put x is minus 1, so y will be minus 1. This will be the point. For a straight line, 2 points are enough, let alone 3 points. It's okay, more points, more clarity, but 2 points are enough to draw the graph of a straight line. Now this is the graph of that straight line. Or you could say that this is the graph of this function. Very simple. This is the graph of this function and the graph is a straight line. Sorry, the graph is a straight line, or this is the graph of this function. Now, what did I tell you in the previous? That if you want to draw the graph, you have to have a right angle triangle. It's up to you. You choose any 2 points, arbitrary points. For example, you selected these 2 points. You will come straight down, you will go straight forward. So once this is your right angle triangle, how much is this? Clearly its length is 2 units. This is 2. And how much is this? Clearly it is 1. It is clearly this is 1. This length is 1. So the slope of the straight line is rise divided by run. Its slope is 2. We say that slope is unique. Slope is independent of rise and run. Of course, you could select 2 different points. There is another student who comes and he selects these 2 points. One point is this one, other point is this one. He comes straight down and he goes straight forward. Students, now how much is this length? Clearly this length is 2 units. From minus 1 to 1 we have 2 units. This is 2. And from here to here, from minus 1 to 3, rise is now 4. This much is the rise, students. This one 4 and run is 2. Again, if you see, slope will be 2. Rise is 4, run is 2, slope is unique. Slope does not depend on the points selected. Slope does not depend on the rise and run. So it is called the slope. So how do we get the slope? Without drawing the graph, without getting into this graphical solution, you could simply solve it by taking derivative. That's what I have written. The derivative shows slope of the line. This is the given function, y is equal to 2x plus 1. You say differentiate with respect to x. You say differentiate with respect to x. This is 2. Students, the graph of linear function will be a number. It will be independent of x. There will be no x. Derivative is 2. And this derivative, we say that it is the slope. What does it show? It shows the slope. You are given a linear function, you differentiate it, you get a number. That number is actually slope. Slope of what? Slope of this straight line, which will be the graph of that function. This is slope. You got the derivative too. It is the slope. Slope of what? Slope of the straight line. Slope of this function, which is a straight line. So without even drawing the graph, we managed to determine the slope of the straight line. Likewise, you say derivative of x is 1. For example, you are given y is equal to x. Derivative of x is 1. Means slope of the straight line will be 1. If you want to draw its graph, okay, it's too easy. This is your x-axis. This is your y-axis, students. And this is your function y is equal to x. If x is 1, y will be 1. It's called identity function. It's a special case of linear function called identity function. 1, 1. Students 2, 2. Minus 1, minus 1. 0, comma 0. X and y are equal. Whatever is x will be y. 0, comma 0 is this point. Students, 1, comma 1 is this point. Minus 1, comma minus 1 is this. Then you join the points and you know that the graph will be a straight line. Normally these graphs, if we have complicated functions, the graphs will be drawn by softwares, with the help of softwares, with the help of apps. Okay, so now what's its slope? You go, you select any 2 points. Suppose these are the chosen points. You came straight down, you went straight forward. Of course, this is 1, this is also 1. Slope is equal to rise by run is equal to 1. The slope is 1. That's what we have obtained by the differentiation of the function. Y is equal to x, derivative is 1. This one shows the slope. Let's discuss one thing more. For example, we have a constant function, y is equal to 2. Derivative of 2 is 0. Means slope will be 0. You know, the graph of constant function will be also a straight line, but it will be parallel to x-axis. It will be parallel to x-axis, and the graph of linear function is a straight line, inclined at some angle other than 0. Right, students? So let's try to understand this with the help of the graph drawn. I have drawn the graph of this function in advance. Actually, your mind, your concept of practical meaning will be explained with the help of this function. So this is needed. I don't want to remove it. Y is equal to 2, students. This is a constant function. Whatever is the value of x, y has to be 2. If x is 0, y is 2, x is 1, 2, 2, 2, and so on. Right, students? All right. X, y. Students, 1, 2. Minus 1, minus 2, 1, 2, 3. Minus 1, minus 2, and so on. Students, 0, comma 2 is here. You don't say, sir, if we put x is equal to 0. So is 0 power 0 is equal to 1. It's called indeterminate case. But in this case, 0 power 0 will be equal to 1. And generally speaking, 0 power 0 is not equal to 1. It's indeterminate case. Its value could be 1, 2. Indeterminate case means a case in which you have multiple possibilities and you select one according to the situation. In this case, we have to have y is equal to 2. Y has to be 2. So whatever is the value of x, y will be 2. X is 0, y will be 2. If x is 1, y will be 2. Right, students? If x is minus 1, y will be 2. This is the straight line. And it has no rise. Or you could say that its angle is 0. And if the angle is 0, derivative will be, slope will be 0, because tangent theta will be the slope, tangent 0, and tangent of 0 is equal to 0. And slope 0 simply means that 0 by anything. This is a non-zero number. For example, you went from this point to this point. So you made a paver run. You made a paver run 3. There is no vertical portion, no perpendicular, no rise. So 0 by 3, slope is equal to 0. If you say angle is 0, tangent theta, tangent 0 is 0, slope is 0. All right, students, hopefully you got the idea. So if the given function is a linear function or constant function, the graph will be a straight line. And the derivative will show the slope of that line. I hope 90% of the students, they know this concept. A slope. That slope. The word I normally use K. It's used in our own language. Students, I have given this whole course, first year, second year, 9th, 10th, but it's in our own language, Urdu, for India and Pakistan. They understand Urdu. I intend to start teaching all these courses in English. I intend. Hopefully within a couple of days I will start. Right, students, so this is okay. Okay, students, let's remove this. Students, derivative will show the slope. Slope of what? Slope of the tangent line if the given function is a non-linear function. If the given function is non-linear function. Non-linear function, students, you know, non-linear function, the graph will be not a straight line. The graph will be not a straight line. And if not a straight line, we say that the graph will be curved. Either you say that the graph is not a straight line, or you say that the graph will be curved. They are equivalent statements. They are which statements, students? They are equivalent statements. Curve, not a straight line. Like this is curve, this is curve. All of these are curves. Okay, not a straight line, curve. Arc, a special case of curve, which is part of circle. This is curve, but it is arc, part of circumference of a circle. All right, students. Now come to the topic. The steeper the graph, the harder it is for us to draw the tangent line. So before getting into this, I want to take a simple compared to this simple curve. For example, students, let's say I select this function y is equal to under root of x, square root of x. Students, is it within the range of the camera? Yes, it is. Students, so then you have no problem. D by dx derivative with respect to x, and I hope you know it's power 1 by 2 x power rule. Subtract 1 from the power before the function. This is power rule. The derivative of x power n is equal to nx power n minus 1. Right, students? This is minus 1 by 2. It will go in the denominator. It will go to the denominator. Power will be 1 by 2 square root of x. Derivative is equal to 1 by 2 under root x. There you saw that if the function is linear function, the derivative will be a number, just pure number. It will be independent of x. That number will show the slope. Here again we have the derivative, but there we see this thing called x. So of course the derivative depends on x. If you change the value of x, the value of derivative will change accordingly. Right, students? Okay. So what is this? This thing shows the slope of the tangent line drawn at that value of x. I said that derivative will be slope of the tangent line if the function is not a linear function. Students, here I write small t, it means tangent, slope of the tangent line. Slope of the tangent line will be equal to this, and you know at different point a different tangent can be drawn. Tangent means a line which touches the circle at one point from outside in the given plane. All right, students. For example, this is a given function. At this particular point, the tangent will be this line. At this particular point, point B, the slope will be, the tangent line will be this. The tangent line will be this. And these are two different lines. They have different angles, and of course, their slopes are different. Its slope is greater than this. The more the angle in first quadrant, the more will be the slope. Its angle is greater than this, its slope will be. I hope you know that if you go to the second quadrant, there will be something different. But forget about greater or smaller. These two lines have different angles. They will have different slopes. It's enough. Sometimes the teachers, they give statements and students start thinking on those statements. Their concepts are not clear on those pre-learned statements. So let's come, students. Let's try to draw its graph. Y is equal to, for the time being, for a short while, let's remove this because I need this space. Y is equal to under root x. Right, students? Let's try to draw its graph. You can't put any negative value. Square root of negative value is undefined. If you put x is equal to 0, y is 1. If x is 1, y is 1. If x is 2, y will be 1.4. No need. You go for exact values. 4. Y will be 2. 4 comma 2. Now, students, this is y-axis. And this one is x-axis. Students, you try to plot these points with the help of a scale, which I have done in this particular case, but it's okay. We will be 99% accurate. 1, 2, 3. Hopefully these divisions are of equal length. 1, 2, students 3 and so on, minus 1, minus 1, minus 2 and so on. Of course there will be a slight error. 0 comma 1, my sweet students, 0 comma 1, this is 0 comma 1. 1 comma 1, 0 comma 0, really sorry my sweet students, 0 comma 0. If you put x is equal to 0, y will be 0. Students, 1 comma 1, this is 1 comma 1. 4 comma 2 will be this point. X is 4, y is 2. 2 comma 1.4 something something irrational number. If we draw the graph, we know that it will be a curve. Of course, the points are in this fashion. They're gonna give us a curve. This is that curve. The more the points, the more clear will be the picture, better will be the accuracy. Students, there will be another topic which I will explain in the next video, that rate of change. Rate of change. If you have full grip on this statement, rate of change, rate of increase, rate of increasing is increasing, rate of increase is increasing, or rate of decrease is increasing. If you understand the meaning of these statements, your 50% physics will be clear. And Faraday's laws are over here. You will now realize this, the importance. This is the given function. Now this is a curve. Curve does not make an angle, so you can't say that how much is the slope of this curve. Slope is property of a straight line. This is a curve, but now we will take a particular point, draw tangent over that point and find the slope of that line. For example, I am interested in this point. For example, I am interested in this point. Let's call it point A. Draw a tangent line. So if I draw a tangent line is this point, students, clearly you see, students, I told you that these minor errors, they will be accepted because we are not computers. So error is human. So my sweet students, then it is this thing, the slope, the straight line. Now how much is its slope? You will have to select 2 points. Let's say these are the 2 points. One point is this one, other point is this one. You have to go straight down, you have to go straight up, straight forward. Students, how much is this? Plus 2, forward direction, plus 2. Plus means forward, 2 means 2 units. And plus means upward in y direction, and 1 means units. So the slope of this straight line is 1 upon 2. 1 upon 2. So you manage to draw the graph, the slope of the line practically. The slope of the line practically. And you could obtain this solution just by putting x is equal to 1. Why x is equal to 1? Because the tangent line is drawn at a point in which the value of x is 1 in the function. You don't say, sir, x is 1 here as well, x is 1 here as well. So what this point has to do with the function? We will take point of the function in which x is 1. No need to mention y, because generally speaking, unless the function is implicit, the derivative does not contain y, so we are not interested in y. We just say that the x of this point is 1. So just put this x is equal to 1, the point of the function, the x value, you put in the derivative and you will get a number which will be the slope of the tangent line drawn at that particular point. This is the slope. Now you put x is equal to 1, students. X is equal to 1. So you will see slope of the tangent line drawn to this curve at x is equal to 1, 2 into this. So square root of 1 is 1, 1 multiplied by 2. The slope is 1 by 2. Clearly the slope is 1 by 2. Its slope is 1 by 2. And if you select this point, of course, here x is different. 4, you draw a tangent line over here. I say once again that error will be there because we are not computers. Once this is the tangent line. This is what is meant by that topic of physics: error, personal error, systematic error. Exact values are given by computers, mathematics. Mathematics will give me the exact value. Somehow I managed to draw the graph because I have the knowledge what will be the derivative by looking at the expression for the derivative. So students, this is that. I will a bit manage it. I will manage the situation. So students, now this is the tangent line. I would say it's 99% correct, students. So then this is the tangent line. Students, one point is selected, this one, the other point is this one. You will have to go straight down, you will have to go straight forward. This is students 4, run is 4, and this is 1, this is 1. The slope of this is 1, rise by run 1 by 4. The slope of the blue line is 1 by 4. The slope of the green line is 1 by 2. How will you find the slopes of these lines without drawing the graphs? With the help of derivative. You have the function, y is equal to square root of x. You determine its derivative and just put the value of x of the point at which the tangent is drawn. Since this tangent is drawn at x is equal to 1, just put x is equal to 1 and you will get a slope of the tangent line. This tangent line is drawn at a point in which the value of x is 4. The value of x is 4, the blue line I mean. So students, x is equal to 4. Slope of that tangent line will be 1 over 2 multiplied by square root of 4. Square root of 4 is 2, students. 2 times 2 is 4. This is the slope of the blue line, 1 by 4. 1 by 2 is the slope of the green line. X is equal to 1. Hopefully you have now the geometrical meaning. You fully understand. You fully understand this, students. So if you think you know the geometrical meaning of the derivative 100% with 100% concept, then we can get into the practical meaning. My sweet students, let me remove this. This is geometrical meaning. Now we will discuss the practical meaning. The second part, which is our today's topic, practical meaning of derivative. Students, normally the students ask that, sir, if we have a function like that function, we just say differentiate with respect to x, means d by dx operator, derivative operator is operated, we get 10x. Okay, sir, no confusion. What does it mean? But geometrically. For example, if I put to students y is equal to 5x square, its graph is given to you in advance. I have drawn its graph in advance just to save time. Right, students, this is the graph of the function. Hopefully you have no confusion. If you put x is equal to 0, y will be 0, 0, comma 0. If you put x 1 by 2, y will be 1.25. X is 1 by 2, y is equal to 5 into x square. 1 by 2 square, 1 by 4, 1.25. So students, this is 1, this is 1.5, this is 1.25, this is what? This is 1.75. This point, its coordinates will be 1 upon 2, 1 upon 2, 1 over 2. And this is 1 over 4, 1 upon 4, 1 upon 4, y. 1 upon 4 means, 5 by 4, 5 by 4. It is 5 by 4, students, this one. 5 by 4 means 1.25. 5 by 4 means 1 whole 1 over 4. One full division, and then in the next division you cover 1 out of 4. So you divided the next unit in 4 equal divisions. This is called 1 upon 4. 1 upon 4 means 1 part out of 4 parts if one unit is divided into 4 equal parts. From here to here is 1, from here to here is 1 upon 4. So 1 from here to here will be 1 plus 1 upon 4. 4 is the LCM, 4 plus 1, 5 by 4, hopefully clear. I mean, this is the graph. If x is 1, y will be 5. You see, there will be no confusion. These are the puttings. This is square even function. If you put x is equal to 1 by 2, y will be this. If minus 1 by 2, again y will be this. This is the graph. Now, my sweet students, once again, just to have connectivity with the previous, for example, if I put x is equal, somebody asks you, okay, that what is the meaning of this geometrically, you say just put some number, just put some number in this x, the value of x. For example, I put x is equal to 1, derivative will be equal to 10 times 1 is equal to 10. What does it show? It shows the slope of the tangent line that will be drawn to this curve, to this function at x is equal to 1. Then where x is 1, you see, this is the only function, and of course x is unique for a function. You can't have 2x in a given function, that it will not be a function. X is equal to 1 is this point x is equal to 1. Try to draw a tangent over here. It's harder but not impossible. We will try to manage the things. My sweet students, this is the tangent line. This is the tangent line. This is the tangent line. Right, students? This is the graph. Let's have a look at the exact graph which will be obtained from a software or app. For example, this is the app I have in my mobile, Math Professional. You select this thing. You select graphical calculator. Students, you just give 5x square. No need to give 5. You just give 5x power 2. This is the graph of this function. You can see. This is the graph of this function. You can study these points. Like this point is exactly 1 comma 5. Then these are the exact graphs. We have softwares, apps. Somehow our is also 90, I would say 99% accurate. Right, students? This is the graph of this function. Now what's its slope? Select any 2 points of the line. I select, students, I select one this point, other is this point of the straight line. Straight down, how much is this? 5. From 0 to 5, the length is 5 units. And how much is this, students? 0.5. 0.5. The slope of this green line will be rise divided by a run. Students, it will be 50 divided by 5. Slope is equal to 10. That's what we have obtained over here. If you put x is equal to 1 by 2, you will get 5. It will be the slope of the tangent line drawn at this particular point, this one. Its slope will be what? If you put x is equal to 1 by 2, derivative will be equal to 10 times 1 by 2 is equal to 5. It is what? It is slope of the tangent line drawn at x is equal to 1 by 2. This point has x is equal to 1 by 2. X is 1 by 2. Y is 5 by 4. The tangent line drawn at this point, the slope will be 5. Right, students? Okay, sir, we fully understand this. We fully, God willing, we will have no problem in the geometrical meaning from now onwards. But now, students, come to the main thing. This thing, practical meaning. This is function. This is the derivative. If you put x is equal to 1, you get 10. Geometrically, it represents the slope. But what does it represent practically? This is a commonly asked question. Now listen, my sweet students, the mathematical things, we give mathematical meaning to the students. We explain the mathematical meaning because what's its practical meaning? It all depends on these things, x and y. You have to mention me what is this x and what is this y. Then I will show you what is the practical meaning of this derivative 10x. Okay. Students, for example, consider the case Consider the case in which you release a body from a certain height at rest. You released a body, let's say this is a ball, marker, stone, because G is independent of mass. This is a mass, for example, and I release it with zero velocity. Don't push it. Otherwise, you will give it initial velocity. You release it from rest like this. So the equation for the distance obtained will be, distance is equal to VIT plus half GT square. You released it from rest, initial velocity is 0. The equation is reduced to this thing, G is 9.8, but we will put 9.8 meter per second square, but we will put 10 just for simplification, 5t square. Alright students, now compare this equation with that equation. Isn't representing this equation? I mean x is representing t and y is representing s. Of course, it could represent some other phenomena, but students, remember, mathematics always speaks physics. In physics, we represent physical phenomena. Like if you compare these two, you will get into the point. For example, if there is a body whose mass is 10 kg and it is moving with velocity, suppose we represent the velocity by x. The equation for kinetic energy will be half mv square, half into 10 into x square, 5x square. It could represent this also. Also v square, v square, v square, v square. So if I compare this equation with this, y is representing kinetic energy and this x is representing velocity. So the point that I want to elaborate is, before getting into the question, before explaining that what does the derivative represent practically. So first you should know, what do these variables x and y, what do they represent? For example, if this x is t and this y is s, the derivative will show me the instantaneous velocity, like I will explain in a short while. And if this x is representing velocity, this y is representing, this x is representing time, this y velocity, then the derivative will show instantaneous acceleration. Likewise, we have phenomena in which maybe x is representing flux, then and y is representing, x is representing time, y is representing magnetic flux, then the derivative will show induced EMF, and so many phenomena. I hope students you got the point, that the practical meaning of derivative, it all depends on what do these variables x and y, input and output, what do they represent. I hope it is clear to you. Okay, move forward. Equation for distance covered by a body released from height at rest will be 5t square. For example, if t is 1, my sweet students, so s will be, shabash, s will be very good, 5 into 1 square, s will be 5. Means after 1 second, the ball will be at this position. After t is equal to 1, t is equal to 0 means starting point. After time t is 1, the ball will be at this position and it would have covered a distance of 5 meters. 5 meters. Alright students. If you put t is equal to 2, let me highlight it with blue marker, s2, 5 into 2 square, it is equal to 20. After 2 seconds, my sweet students, the ball will be at this position. For example, this position. It would have covered a total distance of 20 meters. A total distance of 20 meters when the total time elapsed is 2. The total time elapsed is 2. The total distance covered. Total distance means the distance from the starting point. Total time means the time taken by the body to reach from this point to this point. Alright students, the body at a distance. There are two things. What is the distance traveled in 2 seconds? One is the distance traveled in second. So this much is the distance traveled in the second. distance of in the first second and then distance in the second. This is the distance in 2 seconds. So the distance traveled, that's why we use delta S. That's why when we calculate velocity, of course, it will be average velocity delta S, the distance, the total. This delta S means the change in displacement in that interval. I want to find the velocity when the body goes from this point to this point. The body is continuously accelerating. Of course, these are infinite points, and at each point, the velocity will be different. When somebody asks you that find the velocity from this point to this point, of course, you will find the average velocity. We say delta S by delta D. Delta S means the distance, the difference of the distances. And this is, let's call it point A, let's call it point B. We want to study interval AB. Delta T, the time taken T2 minus T1, this is T2. This is T1, the time taken from this point to this point is 1. Delta T is 1. Right, students? And the distance traveled is S2 minus S1. For this distance, you have to subtract this from the total S2, distance in distance of 2 seconds, S1, distance of 1 second. This distance of the seconds, 20 minus 5 is equal to 15. From here to here, the distance traveled is 15 meters. Time taken is 1. 15 meter per second is the average velocity. It is the average velocity because all of these points, they will have different velocity of the body. Average, you know, sum of all the velocities divided by sum of all the time taken. Like you get 2 marks in one test and 8 marks in second test. Your average marks are 2 plus 8 divided by 2, 5. Your average marks are 5 by 10, as if you got 5 marks in each test. You got 10 marks in 2 tests, as if you got 5 marks in 1 test. Average, like average of a batsman, like average of Virat Kohli, let's say 60, means that his score is 60 in each innings. It's a bit different if he is not out. Procedure is a bit different, but average. We calculate the average if the phenomena continuously changes in that interval. You have to take the average. For example, at the beginning of our class, the temperature was 20 degrees centigrade. When we are about to finish, we measure the temperature, which is 22 degrees centigrade. If I ask you, what was the temperature during our class? So what would you say? Neither you will say 20 nor 22. You have to say the average. Add them, divide by 2, 21. You just say that the temperature in our class was 21 degrees centigrade. Right, students? Okay. Let's move forward. Students, practical meaning. Now, in this case, students, for example, I tell you that what was the velocity of the ball when the time is here. The time changed from 1 to 2. The time changed from 1 to 2. If I take the time, the delta t so small that the 2 points will be almost coincident. In that case, we call it instantaneous velocity, instant, at a point. They are not actually one point, but the points taken are so close, the point chosen are so close that you can consider it a point. You can consider it. And the more the points are closer, the better will be the result. Let's have a look, students. In that example, the time changed from 1 to 2, you determine the average velocity. All right, students. So what if time 1 was 1 and time 2 was 1.0002? Just imagine how small the time is. How small the time is. Here time is 1. And the body will be almost at this. If a time is equal to 1, the body is here. A time is equal to 1.0002, the body will be here. So small will be the distance covered that you can neglect the distance. You can consider those 2 points as a single point. All right, students, now calculate the distance. Delta t is subtract t2 t1 from t2 1.0002 minus 1, it is 0.0002. 0.0002. All right, students. Okay. And what will be the distance? S2 minus S1. S1 is this thing, students. S1 is 5. Now you have to put 1.0002 to get the total distance of this time. 1.0002 square. Students, determine its value. I am finding the value, my sweet students. 1.0002 square, that's the answer. Multiplied by what? Multiplied by 5, that's the answer. Students, 5.00. 5.0020002. Then how much is delta S? Delta S means the distance traveled when the time went from 1 to 1.0002 in my watch. So small point, so small delta t. Then delta S will be 5.0020002 minus 5, students, 0.0020002. This is the distance traveled in this small time. When the time is 0.0002, it is 0.002002. Right, students? Okay. Now you divide it minus 5. You got this thing divided by 0.0002. You got this number, students, 10.0001. 10.001. Almost 10. Almost 10. Now the 2 points are so close to each other that you can consider these 2 points as a single point, and consequently the velocity is called instantaneous velocity. It's a mathematical concept. I don't want to get into that much detail because medical students may be listening to my these words. Instant and instantaneous velocity, we define instantaneous velocity as delta S by delta t. Limit is a simple topic of mathematics. Delta t tends to 0. Tends to 0. The more closer delta t is to 0, the better will be the result. Now you can't say it means that delta t tends to 0. You make delta t as close to 0 as you wish, as you can. In that particular case, delta t is 0.002. We could have taken this t2 such that delta t is 0.0002. For this delta t, almost the 2 points will be coincident. It can be considered as instantaneous velocity, but if we make it more closer to 0, the result will be better. Compared to the results will be more accurate, less error. More accurate in physics, you say, less will be the error. All right, students, so this is a very tedious process we did. We did very tedious process. So if the times are given so close to you, so very, very close to each other, you could obtain the instantaneous value by just putting values in the derivative. So students, this is derivative. Okay, I told you what is the practical meaning of derivative. This was the question. My sweet student, this was the question. What is the practical meaning of derivative? So you have to say, what do these x and y, what do they represent practically? So now you say, if this y is s, if this y is s, and this x is t, it will become now x is t, x is t. then it shows derivative shows instantaneous values, and of course distance over time is velocity. You said that this is the expression for the instantaneous velocity. My sweet students, now you came to the point. Instantaneous velocity, derivative of s with respect to t will give you the instantaneous velocity. V instantaneous students, this one s is given to you. S is given to you 5t square. S is given to you 5 s square. 5s is given to you 5t square. You say derivative with respect to t. Derivative with respect to t. My sweet students, it will be 10t. ds by dt. Now what is it? Now it is clearly mentioned. One is s, other is t. So derivative of s with respect to t will give you velocity. But what velocity? Which velocity? Instantaneous velocity. And then you put t. Students, v instantaneous is equal to 10t. You just put t. Which t? Starting t. This one. t1. So t is equal to 1. Instantaneous velocity will be t. Instantaneous velocity will be 10. Instantaneous velocity will be 10, students. This one. It is not exactly 10, but the more closer delta t is to 0, the more closer will be the instantaneous velocity to 10. If you make delta t more closer to t2, more closer to t1, suppose delta t is this thing, then you find the value. The value will be this one. It is more closer to 10. It is more closer to 10. For example, I say, accordingly, this will be changed. But this one, if you take delta t, this thing, velocity, instantaneous velocity will be 10.00001. Clearly, you see that the limit of the velocity gets closer and closer to 10. As delta t gets closer and closer to 0, we say instantaneous velocity will be 10t. You got the points, students. Now just think over it, how difficult it would be to determine the instantaneous. Not impossible, but will be very difficult compared to this derivative method. Very simple, my sweet students. This is given to you, s is equal to 5t square. He says, find the instantaneous velocity as the time goes from 10.51 to 10.52. Very difficult comparatively. You have to put t1 in this, then you have to put t2 in this. You get s1, you get s2, then you get delta s, then you find delta t. Delta s by delta t will give you instantaneous velocity, and I am giving it to you in advance. Students, what will be the expression for the instantaneous velocity? Derivative of s with respect to time. Students, it will be 10t. Just put this thing, t is equal to 10.51, 10 into 10.51, students, 105.1 will be the instantaneous velocity. When the body, because as it gets closer and closer to the earth, it gets lower, its velocity increases. In 1 second, the change in velocity will be 9.8 meter per second, students, acceleration. So at this particular time, the instantaneous velocity will be 105.1. Students, how did you know that this is equal to instantaneous velocity, this thing? So if you compare this expression with that expression, the dy by dx is actually nothing but change in y by change in x, and change in x tends to 0. Limit, I want to skip the limit. Right, students? Now, if y is s, x is t, my sweet students, if this is s, this is t, what do you see? What is this? My sweet students, it is clearly a definition of instantaneous velocity. Delta s by delta t is velocity, but delta t tends to 0. It is instantaneous velocity. So now, you tell me, what is this dy by dx slope mathematically? What is its practical meaning? You just say that what is this y and what is this x. If this y is v and this x is t, derivative of v with respect to t, it will give you instantaneous acceleration. In second year, you will say in a particular chapter, induced EMF, if this Y is change in flux, sorry, if this Y is flux, magnetic flux through a coil, and this X is T, then it will give you induced EMF, instantaneous induced EMF. You will rotate a coil in second year physics. This is a coil. We are rotating it with constant angular velocity. Velocity is constant, but at each different position, different EMF will be induced. You will do this topic in physics. Alright students, so that's what I want to tell you, that what is this derivative practical meaning. You just ask, what does this Y represent and what does this X represent? If X represent, normally in physics X represents time, not necessary. Normally I say you have to remain to your own level, so be within your limits. You say as if this X is always T. Now Y, if Y is S, it will give me instantaneous distance. If this Y is instantaneous velocity, if this Y is velocity, this will tell me what? This will give me instantaneous acceleration. If this Y is flux, this is time, it will give me induced EMF. And so many other thousands of examples we mathematicians know. But for now, I believe that your concept about the practical meaning of derivative is clear. I tried my best. I will record another lecture on this topic as well. In this lecture, at least you came to the basic understanding of this geometrical meaning of derivative. Until next lecture, take care. Do remember me in your prayers and don't forget to share my lecture with your friends. God bless you.